Right. So this is just an overview. We are not going into deep details, but and also this lecture is based on lead 2, and also what is given in Sri Lanka Green Building Council version 1. So this is not the latest or state of the art, but methods are the same. Whether you are using it today or 5 years ago, the construction materials do not change, the techniques do not change. But the evaluation method can change because you know what happens is the leadership in energy and environmental design, that all started somewhere in year 2000. And then, so before year 2000, people were just doing things which are called sustainable, but we did not have any evaluation method except BREEAM. So BREEAM is the method developed by in England, and then Americans started doing it. Now Americans are leading the scene because many people have started following the American method. So they are also tightening. So they also introduce updates. So if you are doing, if you want some recognition, you have to apply for evaluating the project, and they will. You have to submit information about your project. They will evaluate it, and then they say, okay, your project is of green lead platinum or lead gold or lead silver or lead certified. So if you can achieve lead silver or lead gold, it's a very good achievement. So they themselves say achieving lead platinum is a dream. But we have many lead platinum buildings in Sri Lanka. We were also involved in a very big project. And in 2009, I think 2010, we did the project earlier, but in 2010 we got lead platinum recognition for a new factory, the world's first lead platinum certified factories in Sri Lanka. Then you'll ask, what is the first building to be certified in Sri Lanka? And that is Kandalama Hotel. Kandalama Hotel was built in 1991, and there were protests and all kinds of problems. But now nobody protests, everybody is proud of this hotel. And that hotel was designed by the famous architect Jeffrey Barber. And for his design, the project was recognized as lead bronze those days, lead bronze under first version. And later they changed the name from bronze to certified, lead certified. And in 2007, we designed this particular factory, and we got things sorted out. And 2008 April, it was opened, declared open within 6 months of laying the foundation stone. And then still the construction went on for a few months more to make things even better. And today we are going to talk about that factory, that project. And there are a few other projects where we can get information. So green rating systems for Sri Lanka, prerequisites, sustainable size, water efficiency, energy and atmosphere, materials and resources, indoor environment quality and green technology. Now, one of the important things about Sri Lanka is we also have our own green certification scheme, which is called Sri Lanka Green Building Council. And in Sri Lanka Green Building Council, we have done things we are fairly close to US Green Building Council. So the advantage is, if you are designing, you can design for US Green Building Council. So these schemes go hand in hand. You can first apply for Sri Lanka Green Building Council, get its certification, and in the meantime, you can apply for US Green Building Council as well. So this way, you can assure, if you are doing some manufacturing for international market, sometimes they like to buy things that are made in green factories. So, what do you know about Sri Lanka? Who is the batch rep? I like to get some feedback. Who is the batch rep?
Yes, sir, I'm the batch rep.
What's your name?
Sir, I'm Bimali.
Bimali, this is your batch.
Yes, sir.
This is the batch I did semester 5 masonry. I did it for this batch.
Yes, sir. And also semester 7 building engineering as well.
The dawn batch. I was not sure. This semester 8, is that right? Okay.
Yes, sir.
You are the senior most batch in the university at the moment, right? Okay. Bimali and Randula.
Yes, sir. Randula is not doing the module, I think.
Yeah, Bimali is doing it, right? Okay. So today, Bimali, we are having this. I'm going to talk about modern organic farming as well. Right?
Yes, sir.
So you all can join, because you can learn something that is very important for this subject. Right? There's a lecture 5:30 ISL. I send the link to you.
Yes, sir. I got it.
You can share it with all your batchmates, and you can ask all other friends to join it. Right? You can give publicity, because this is a very important lecture. Right?
Yes, sir.
So basically, buildings affect the environment in many ways, but we have to first see whether you know about Sri Lanka. What do you know about Sri Lanka? For that, I will get another presentation. Can you see this screen? Introduction to Sri Lanka?
Yes, sir, we can see.
Yeah. Now, these days, when you are talking about these sustainable designs, construction, one of the important things is, what's your carbon footprint? What is the carbon footprint of USA? 70 tons. Canada 14 tons. Germany 9 tons. UK 7.6 tons. France 5 tons. South Korea 12 tons. China 8 tons. Malaysia 8 tons. Thailand 4.5 tons. India 1.6 tons. What is Sri Lanka? 1 ton. So that means, we are not polluting the world. It's a good country. Who is the biggest polluter in the world? USA. They use so much energy per capita. They produce the highest amount of carbon. What is the effect of this carbon dioxide? Carbon dioxide is a greenhouse gas. And when the industrial revolution started, the carbon dioxide content was only 270 parts per million. What is the value today? It has exceeded 400. Then you'll ask, so what? Do you like to breathe oxygen or carbon dioxide? Vimali? What do you like to breathe? Oxygen or carbon dioxide? Are you missing?
Sorry, sir, what?
What do you like to breathe? Carbon dioxide or oxygen?
Sir, oxygen, surely.
Yeah. So oxygen. So what will happen if the carbon dioxide content increases? Oxygen content will go down a little bit. But this carbon dioxide is not a very good gas. When it exceeds 450 ppm, it is a greenhouse gas and it can create some trouble in the world. Sometimes the world climate can change in a manner that it does not change back. Unfortunately, COVID came and people stopped many activities that allowed the carbon dioxide to settle a little bit. So if the carbon footprint of Sri Lankans is less than 1 ton, what can you say? Are we a good green economy, or that does not affect the world, or an economy like USA, which can actually affect the rest of the world? We are a good country. What else you know about Sri Lanka? Sri Lanka is an ideal country for solar generation of electricity. But solar generation was very expensive some time ago. Now it has come down to a very reasonable level. And more, you can see most of the people are now going for solar panels on their rooftop. Government was promoting it, then they were not doing much. But again, you see, because of present power crisis, government is keen to see that a lot of people installing rooftop solar. What else we can do in Sri Lanka? Sri Lanka is having a tropical climatic condition. If you are living in a cold country, what is your problem? Outside is freezing, 0. You don't like 0 degrees inside the house, so you have to heat it up. So that the indoors can be anything between 18 and 21 degrees. Now to keep this inside warm, we have to produce a lot of energy and use this energy to keep it warm. And the energy can come from furnace oil, it can come from diesel, it can come from coal, it can come from electricity. One or the other, you need energy to keep it warm. And you don't like to, once you warm up, you don't like it becoming cold. So how do you prevent it becoming cold? We'll make use of what? Insulation. Whereas in Sri Lanka, we have tropical climatic conditions, so we don't need any insulation for our walls. We don't need any insulation for our walls. So what can you say about the construction in Sri Lanka and in England? It's very easy to do the construction in Sri Lanka because what you need is just a wall. If you can make it a load-bearing wall, then you can make it complete. So you have to think about various materials that we can use and what are these materials, how these materials are made, what is the embodied energy, what is the operational energy, how the operational energy is affected by the building materials, and then what is the overall energy and how could that contribute to the carbon footprint of the building. So there are a lot of calculations to be made in the subject. So there will be a lot of theoretical aspect in addition to the qualitative statements. So we can have so many different building materials, earth-based building materials like cement-stabilized earth blocks, cement-stabilized rammed earth. Then sometimes even for the foundation, we can use cement-stabilized rammed earth provided the water table is low. And recently we have started making panels, lightweight panels in Sri Lanka, where 80 to 90% is expanded polystyrene, which is actually a waste material. Because we have free trade zone, we import a lot of things. So a lot of regiform comes to Sri Lanka. And there's no way you can get rid of it. So we put it into a panel and make a lightweight panel. And you can use EPS for making blocks. And in addition to that, we can make cement stabilizer blocks, concrete blocks, and all this. Then we have a factory in Putlam owned by a professor at Peradeniya University. You know Professor Andit Disanayak. He's one of the owners of that factory. And then there's another engineer called Nalin Patirana, very good engineer. But now he wants to innovate all the time. But now he's not doing a job. He's his own boss because he runs a garment business called Tailor's Store. And if you want to buy a shirt, you design your own shirt using a software. And then you take 2 photographs and pay $60 per shirt. After 10 days, you'll find the shirt that you designed and ordered is at your doorstep. So that is the kind of operation this very intelligent engineer is doing, and he's the other owner of this factory. Now Access Group has already joined with them, and now they have put up another factory. So likewise, they are doing a lot of business, and you will find that there's another product available. That is called autoclaved blocks. Right. I think sessions. I think it might be a better idea to use make use of this one because it has more photos. Okay, I'll make use of this presentation today. And I can email this presentation to you. These are a lot of photos. I think this is better. So I'll make use of this presentation. Right. So basically, this is a presentation I did in 2018-19 at CEDA Auditorium. Sustainable Materials and Construction Techniques organized by Construction Industry Development Authority, CEDA, in collaboration with ISL and Sri Lanka Green Building Council. So we'll make use of this presentation. So I'm talking about various projects. So it is a better presentation to make it good, make it understandable for you. Buildings affect the environment in many ways. Development of previously developed sites consume land and may encroach agricultural lands and wildlife habitats. So basically, if we can make use of the land that is already built, it's better. Otherwise, we are going to encroach onto the good farmlands. Increased impervious surface can increase runoffs, causing flash floods. Roads may be converted to waterways, which is a common experience for us. Sediments caused by erosion can affect. And when you have a lot of buildings, then we find that there's something called heat island effect that will make the temperature around us higher than the surrounding suburban areas where there are a lot of trees. When buildings are constructed, it can affect neighbors. Wastewater generation is a big problem. Solid waste generation generated during construction and even after, when the building is used, again, should be handled. And we use a lot of energy for visual and thermal. But because buildings are having a roof, we can generate electricity. So if you are a professional undertaking a project, you must be aware that buildings can affect the environment, and because of that, you must be careful. And that's why we go for sustainable design and construction practices that can limit the environmental impact of buildings on local ecological systems and their contribution to global issues. And I explained this part. There are so many different building materials. We see how these building materials can be used. Project done in 2007-2008, completed within 6 months. After we placed the foundation stone, somewhere in October, this building was declared open by the chairman of MAS, chairman of Marks and Spencer of England on 21st of April, just 6 months. And you can see the type of materials used. This is cement stabilizer. This is a factory overlooking a pond. So if you are doing a green project, the first thing is you must protect the environment by removing all the topsoil, stacking it somewhere so that it can be used later. So first we have to do erosion and sediment control. And also you have to make sure there are silt traps. And safety for site workers, those are basic things, and dust control. Let's see, what is the material they use for external walls? Cement stabilizer blocks, solid blocks. Size 240 millimeter by 240 millimeter by 100 millimeter, 80 millimeter. Very strong blocks, constructed by using 5 to 6% cement with lateritic soils. Right. So first thing is cement stabilizer blocks. And you can see very nicely done design with reinforced concrete. These columns are sitting on water. Rainwater harvesting, there's a big roof, all the water is collected, rainwater harvesting. These are the water tanks on top of washstones. All designed by engineer Juan Zenecker of Marga Engineering in those days. Now he is running his own firm. And his firm has designed the tallest building in Sri Lanka, which is under construction, having 77 floors, twin towers, with a helipad at the top, connecting in the connection portion of two buildings. Very good engineer. And you can learn a lot from him. And then there's ducting system. And this ducting system allows the cool air generated in evaporative coolers to be distributed. And this is a duct network. Let's see all the information. And the cooling system used consisted of evaporative coolers. And to learn the technique, I'll teach it later. Today we just learn. It is all evaporative coolers that created the cool air, and then we supplied it inside. So you can see the arrangement of coolers. This theory, we'll come to the theory later. Did I cover this theory for building engineering, Bimali?
Yes, sir. You covered it.
How to get the effect of physiological effect of cooling?
Yes, sir.
Into account?
Yes,
right.
Sir.
So you can understand these diagrams. Then we use solar energy and semi-stabilized earth walls above the roads. Again, semi-stabilized. Very good achievement. And it was very big cost saving. And here you can see the interior of the conference hall having evaporative coolers. Hello. Mama lecture again, you're not called. So you can see modern office, semi-stabilized walls. So we have the gadgets out of timber and modern entrance. And this is a dining hall with a lot of daylight. Again, very well equipped areas. And you can see all the floors are cemented. No expensive tiles, but they are just cemented, but polished. And the way that the buildings are planned, you can just see outside. All these trees have been grown so that these courtyards will be covered by trees in 5 years' time. The floor is out of steel. On top of steel, we have got used timber and then supported the floor, created the floor. And you can also see green roofs. Green roofs. This is not at the ground level, this is at a high level. And then we have used a lot of plant and a lot of native trees. Then there's an artificially created pond, so that we can have a treatment plant, and all the excess water of the treatment plant can be, after all the treatment, can finally end up in the pond. This is the factory. Then, whenever you do a green project, it's very important to control the storm water. For that, we did a cascading type landscape. And all the cascade consist of water detention areas. These are flat. So when the rainwater falls, it will be detained in this area. And you can see factories at a much lower elevation than this. And we also constructed roads using cement stabilized earth. Now I have developed a method where you can have very durable roads. We call it construction of concrete roads without using concrete. Construction of concrete roads without using concrete. And I'll explain what is meant by that on a later date. Bimali, you want to remind me?
Yes.
Yeah, take down and maintain a diary and make sure you remind me about the lecture on constructing cement stabilized earth road, which is finally completed as if we have done a normal road. And you can see nicely on the cement stabilized earth road, water tanks and so on. And you can see the roads, light color roads, and these roads will heat up less and contribute less to the heat island effects. The next project is Nelung Art Center. And if you have been to Hyde Park Quarter in Colombo, and then there's a big Arpico, and next to the Arpico is Nelung Art Center. Project done in 2010. Original estimate was 115 million. So we gave Maga Engineering a contract to do the construction for 62 million rupees after redesigning the structure. It's a nicely done structure. Again, the structure designs are by engineer Juan Zenecker. He did the designs, and his designs are very economical. So you can see very nice building. And this is the dancing academy of a ballet dancer. And attractive interiors. And you can see very attractive interior. This is a huge external wall. We did it without plaster because it's on the boundary, but it's always we have to water. Right. Now this is a wrong picture. These are photo taken of a building, two-story building in Panadura, where the slab consists of beam slab system, not a solid slab. And these slab panels are precast, beams can be precast. So a lot of things are precast, so the slab can be completed at a very low cost and also much lower time. Right. So with this, shall we take a break, Bimali? After that, after the break, we'll take 10 minutes break.
Yes, sir.
We are supposed to stop after 40-45 minutes. Generally, we are expected to stop. So we'll join again around 11:50, and then there are. Oh, shall we continue for 5 minutes more and then stop? We'll continue for a few minutes and then stop. Then you can think in situ cast semi-stabilized rammed earth. Now you can see how it's cast. We cast columns with a 7 feet gap because plywood sheet is 8 feet. Then we can fix the plywood boards and fix it tightly so that we can do a construction very fast. And then you can use semi-stabilized earth for retaining walls, car parking areas, and also can be used for construction of houses. This is a kind of a meditation center in Anuradhapur. And this is a very special project in gold, where you can see even the foundation is out of semi-stabilized rammed earth. And the retaining walls are out of semi-stabilized rammed earth. Foundations are out of semi-stabilized rammed earth, retaining walls are out of semi-stabilized rammed earth, and the walls are out of semi-stabilized earth blocks. And you can see the situation. Then the library. We were not involved. One of our lecturers from architecture faculty was involved in this project. And Dr. Milinda Pathiraja was involved. And this is the army library in the army camp at Abepus. Very nice place to visit. It's a very well kept army camp. And inside the army camp, you get this library building. Very nice place. And all the walls are out of cement-stabilized rammed earth. And this is the exterior wall, which actually needs some ridge tiles to cover it at the top. Because it's not covered at the top, it's exposed to elements, but still you can see no erosion. No erosion. Then Nikambo Hospital. The walls are out of straw. This is called Dura panel. We have done testing of Dura panels to construct houses like this, actual loaded. And then we constructed a 2-story house out of Dura panels and timber floors. And even the flooring material is Dura panel, straw panel, this house, and this is a completed house. And you can see there's no difference between a normal house and a straw panel house. Very well done by International Construction Consortium because they own the factory at Giritale. They own the factory at Giritale. And this was constructed close to the sea. And people are not convinced about the strength of Dura panels, so they got an elephant standing on the Dura panels. And then these are the buildings at Nigamo. And once you erect this steel frame, these precast concrete panels are placed on top of that. After that, you place reinforcement, and then we do the concrete. And using this method, we were able to construct buildings very fast, two-story buildings very fast, because first you fabricate the steel, manufacture at the workshop you cut and prepare it to the correct level with bolt holes and all that. And then it's brought, the steel frame is fixed. The moment the steel frame is fixed, the precast panels can be placed, then the top concrete can be laid. Like this. And then we do the cladding. Cladding is zinc alum sheets. Interior is straw boards, where cement fiber sheets are mounted. What is the advantage? You can wash the floors. You can wash the walls. The main advantage is you can wash the floors, you can wash the walls. For a hospital, the ability to wash the walls is very important, because sometimes the patients come after accidents, then there can be contamination due to their blood and all that. So because of that, it's very important. We should have the ability to wash the floor and the walls. So what we did was, because the floor could be washed, we had the skirting. And when you are fixing the Dura panels, we ensure that they do not touch the bottom. We are at a slightly higher elevation so that we have a small gap. And this ceiling. Ceiling is supported on the C channels that is used to support this panels. The roofing sheets. The purlins are there to support the roofing sheets, and the bottom of the purlin we use to support have the ceiling, so that you can see the structure, but you can't see the sheets. Only the cement fiber sheets. And you can see they are huge, 15 meters wide, 45 meters long. And these are operation theaters. For operation, to conduct operations, we have to have operating theaters, 4 numbers of operating theaters. And they were all air conditioned with laminar flow diffusers and 100% recharge. Why we need 100% recharge is when we are performing an operation, if there's any kind of contamination, it has to be looked after. So what we do is we do not reuse the air, we simply dump it outside. So you'll ask, what is the cost of these buildings? 3,500 rupees per square foot. Then you'll ask, how long will it last? If you are going to look after the building, it can last 100 years. And they wanted temporary buildings, we gave permanent buildings, which could be erected at a faster rate than the temporary buildings. Then we ask them to call them as semi-permanent. Then you'll ask, what is the lifespan of a semi-permanent building? 100 years or more. This is progress. 6th July, no building found. They are doing the foundation. 16th July, buildings are coming up. 23rd July, 24th July. Sorry, 24th June. Because the 2 buildings have been completed. Very rapid construction. And this is a 3-story building. very low cost. And this is a complete 3-story building. Completed in less than 1 month. Right. So we'll stop at this point. We'll meet again around 11:20. Bimali?
Yes, sir, sure.
Sure. Okay. Okay, Bimali. Right. So you can see 3-story building has been completed in less than 1 month.